Hello?
Are we still starting in 5 minutes time?
Yes, we can start now.
All right, thank you.
Yes. I don't know how many we are here. We're about 9 in total. So maybe some people will join us along the way. Welcome to this first training we are doing on Zoom for the KAPEK Kenya Mathematical Olympiad. Over the last 3 weeks, I think we have sent out some two sample questions, two sets of sample questions. Each set has 4 questions. They are not very difficult questions, not very advanced, but I think they would cover something like what we do for round 1 in the KKMO. So the aim here is just to go through the questions and see if this will be useful. Going forward, we will be looking at doing some training on specific topics so that people are better prepared to participate in the competitions. So I'd like to also mention that we have my friend here from it's Finland or Sweden? Andreas, it's Finland?
Yes, Sweden originally, but now I'm in Norway.
Oh, Norway, sorry. So Andreas, I've known him for a while. He did some teaching back in the days at the University of Nairobi, and he's also involved in training for the Olympiad programs. There's something he's working on. I don't know if I should give him a minute to just say what he's working on.
Hi, James, and hi, everyone. Thank you. So I think I will tell you more maybe in 2 weeks' time. But I've been working with the Norwegian students for the Mathematical Olympiad. And I've only been working locally in the town where I live. And the goal for this project is to create some kind of national training program for Norwegian students to begin with. And then if it's a good program, then hopefully other countries will also be interested in this training. So the topic I will discuss with you, James, I think is whether we can set up a collaboration already now, and whether we can match this so that it fits also Kenyan students. So we will see. We will talk about it and see what happens.
Okay, thank you very much. So the reason we need the help is because we did a lot of training for the International Mathematical Olympiad. The mathematics involved there is much more advanced, and the students usually require training for that. And
yeah, the same in Norway.
Yeah. So this would be useful for our students as well. And Norway they have more experience than us at the IMO, so we have something to learn from them. So I'll just go ahead and share my screen, and we go through the questions. And you feel free to ask to ask questions in between. If there's anything I say that is not can you see my screen?
Yes.
Yes, it's okay.
Okay, so I'll just put it in. Oh goodness! I need to move something here. Minimize this. Okay. So now we have it in full screen mode. You can still see clearly, I hope. So
it's okay.
So I've started in reverse. This was the second set of questions that was sent. I'll move to the first set after we are done with this one. So let's look at the first question. The first question is, it says, if alpha plus beta is equal to 17 and alpha beta is equal to 70, find the value of alpha minus beta. So the assumption here is that alpha and beta are just real numbers. So the solution follows. So we can create a when you look at the question initially, it may not be clear which direction to go, but it has, you can come up with some ideas. One of them is to think in terms of the roots of a quadratic equation, so that the sum of the roots would be 17 and the product would be 70. And when you set up such an equation, that would be what we have here. X squared minus 7x plus 70 is equal to 0. So, and then when we solve for this, we find that x is, the roots now will be 7 or 10. So the difference, the absolute value of the difference between the roots therefore would be 3, because 7 minus 10 or 10 minus 7 is 3. And if you work it out in reverse, 7 minus 10 is negative 3, and the absolute value is still 3. So the trick here is just to think of this as the roots of a quadratic equation, then set up the quadratic equation, and then find the possible roots and get the difference and get the absolute value. So one thing I'll mention is that the solutions we have are not necessarily the only solutions. So it's possible to come up with other, maybe even better solutions. So I will move to the second question. So this one says the difference between the highest common factor and the lowest common multiple of x and 18 is 120. So we need to find the value of x. So again, here you'll have to assume x is an integer. Maybe we should have mentioned that in the question. Now, we go to the solution. We label the GCD of x and 18, we call it k. And then if we divide 18 and x by the greatest common divisor, we get these two numbers, a and b. So where a is x over k and b is 18 over k. So this guarantees that the only common divisor of a and b will be 1. Because if the common divisor of a and b is different from 1, then that means k cannot be the greatest common divisor. So there's this formula we can use that connects the product of any two integers. If you multiply any two integers, it's the same as multiplying the greatest common divisor of the two integers and the least common multiple of the two integers. So remember, we had already labeled the greatest common divisor of x and 18 to be k. So we can write this as 18x is equal to k multiplied by the least common multiple of x and 18. So we divide both sides by k. If you divide both sides by k, then you have 18 over k multiplied by x is equal to the least common multiple of x and 18. But we know x, if you use this relationship up here, you can replace x with ak. This one gives you x is equal to ak, and then this will be the least common multiple of x and 18. So the least common multiple of x and 18 is a, b, and k. So the question already told us that the difference between the GCD and LCM is 120. So that if you did this, the GCD is k and the LCM is KAB, the difference must be 120. So we'll use a few more tricks to move closer to getting the answer. Okay. So we know that this difference is 120 from before. Now we can also there's this relationship here which says that the GCD of AB minus 1 and B must be equal to 1. So if it's not equal to 1, then it would mean that B is a factor of 1, which is not true. So the only option is the GCD of AB minus 1 and B is equal to 1. So that means if you multiply AB minus 1 by K and B by K, then the GCD of K multiplied by AB minus 1 in brackets and KB must be equal to K. So that becomes the greatest common divisor of the two. But we know what these two are. KB is actually 18 based on our previous work, because you know B is equal to 18 over K from the previous work we had. So KB must be 18, and KAB minus K is the difference between the LCM and the 60, which is 120. So this should be an equal sign here. I think that was an error. So this will be equal to GCD or 120 and 18, which is equal to 6. So now we have found the value of K. The GCD is K. So from this it's easy to go back and see that B is equal to 3, because 18 over 6 will be 3. And if we go back from star up here, we can get A to be 7, and therefore conclude that X must be 42. Because if A is 7 and K is 6, so 7 times 6 will be 42. So I'll move on to the next one. So the third one says, suppose P and Q are prime numbers, and it is known also that P and Q are the roots of this quadratic equation for some integer M. What is the value of P over Q plus Q over P? That is the question we have at hand. So again, this takes us back to the theory of quadratic equations, and using the formula for the sum of the roots, we have P plus Q will be equal to 99. Now we know that P and Q must be prime numbers. And if they are both odd prime numbers, then it's not possible for their sum to be equal to 99, because the sum of two odd numbers will always be even. So that means that one of the primes must be even. Now the only even prime that we know is 2. So we fix one of them to be equal to 2. And the second prime, please switch off the mic so that we, good. So the only option you have is one of them must be 2, and then that forces the second one to be 99 minus 2, which is 97. So once you have the values of P and Q, you just put them back into this expression, and you'll obtain the value to be 9,413 divided by 194. So here we use some, once you are done with the quadratic equation, it's just a bit of logic to figure out that the sum of two odd primes cannot give you another odd number, and therefore one of the primes must be an even number, which is the only option for the even prime is 2. So then the second prime number must be 97. Then the rest follows. So I will move to the last question in this slides. So this last question says, given that W minus 1 over W is equal to 5, find the value of W plus 1 over W, brackets, squared. Okay, again, here initially, when you look at it, you have to find a way of getting W plus 1 over W from W minus 1 over W. So what we did here is we squared W minus 1 over W, and that must be equal also to 5 squared. And with a little rearrangement, you end up with W squared plus 1 over W squared will be equal to 27. So we also observe that if you square W plus 1 over W squared, if you square W plus 1 over W, you get W squared plus 2 plus 1 over W squared. But you have already obtained the value of W squared plus 1 over W squared, which is 27. So you can just plug it back into this equation.
Perfect, yeah.
And you obtain the value of W plus 1 over W squared. So 27 plus 2 is 29. And the answer for this is W plus 1 over W squared is equal to 29. So I don't know if there are any questions on this one. So like I said, there might be other ways to solve this. The focus has been to try and use techniques that are accessible to high school students. So sometimes there can be more advanced ways of solving some of these problems, which would sometimes even be shorter. But the idea is to make sure that the solutions are accessible to even a Form 1 or a Form 2 student. So
can I ask a question?
Yes.
After this, are you going to share these slides with us by our emails?
Yes, I think they may have been sent.
All right.
And they're also available on the website.
Okay, thank you.
But I can share still again. I
Right.
can also put them on the WhatsApp group.
Okay.
Yes. Okay, so I will stop sharing this one and put up the next set of slides. So I think you can just confirm if you can see my screen. So this was the first set of questions that we sent out for the students. So we will go direct to the question. The first question says, how many zeros does the product of 25 raised to 5, 150 raised to 4, and 2008 raised to 3 end with? So we can, so we are looking for the number of zeros at the end of this product. So the smart way to do this is to find the highest power of 10 that appears in the product. So the highest power of 10 will tell us the number of zeros that appear at the end of this product. Now to find the highest power of 10, you need to pair the 2s and the 5s. that appear in the prime factorization of these numbers. So when you get a prime factorization of 25 raised to 5, it will be 5 raised to 10. Prime factorization of 150 raised to 4 will be 2 raised to 4 times 3 raised to 4 times 5 raised to 8. Because 150 is 25 times 2 times 3. So if you split it into the prime factorization, that's what you get. 2008 cubed will be 2 raised to 9 multiplied by 25, or 5 squared, if you like. So to find the number of zeros, we must pair the 2s and 5s. And so we need to look for which one has the, between the 2s and the 5s, which one has the lowest power. Now that will give us a number of pairs of 2s and 5s. And we see that 2 has the lowest because we have 2 raised to 9 and 2 raised to 4. When you multiply all the three numbers, the power of 2 will be 2 raised to 13. And the power of 5 will be 5 raised to 20 because we have 5 squared here. We have 5 raised to 8 and we have 5 raised to 10. That gives us 5 raised to 20 in the product. So it means the only pairs that will be available will be 13 of them, so that the rest of the 5s will have no 2s to pair with. And that means there are 13 pairs and the product must contain 10 raised to power 13. And that means we'll have 13 zeros at the end of the product of these three numbers. Okay. So we move to the next question. So this question asks, what is the remainder when 7 raised to 2016 plus 9 raised to 2016 is divided by 64? So there are a number of ways you can approach this question, but we thought we should approach it using the binomial theorem. I believe this is accessible to students. They probably don't do I think they don't do combinatorics anymore. The permutations and the combinations, they don't do in high school, I think. But it's good. This competition is supposed to let them learn a few things outside or a little beyond what they do. So this would be a good opportunity for them to expand their knowledge. Now, we want to see what the remainder is when this number is divided by 64. So a good way is to find how many 64s appear in each of them and what is the remainder after we take out all the 64s. If you look at this, we have 7 can be written as 8 minus 1. Now, the reason for this is that if you square 8, you get 64. And any higher power of 8 also will contain a 64 in it. So this is a good way to look at it. We can do the same for 9 again. 9 can be written as 8 plus 1. Again, the reason for that, if you square 8, you get 64. And any other higher power of 8 will also contain a 64. And 1 will not be affected much by raising it to any other power. So it makes it easy to capture all the 64s that are available in each of the numbers. So for 7 raised to 2016, here we have the expansion, the binomial expansion for it. So the first will be 8 raised to 2016. So it definitely contains an 8 squared in there. And any number that comes after that all the way up to before the second last term in the expansion contains a 64, because it will have a power that is higher than, or a power that is at least, a power of 8 that is at least 2. That means it must contain a 64. So this is the one we have to worry about. 2016 times 8. Does it contain a 64? And yes, it does, because 8 is a factor of 2016. So the only number that has no 64 as a factor is 1. That means this first section of this expression can be written as a multiple of 64 plus 1, because every term in here contains 64 as a factor. So that can be written as 64, p plus 1, where p is some integer. We use the same idea here. Again, the only term that we need to worry about is this second last term. And it will have a 64 in it, because 2016 has 8 as a factor. Again, we can write everything before this last term as a multiple of 64. So we write it as 64k plus 1. Now, when we add them, we get a multiple of 64 plus 2. So that gives us the answer. The remainder, when we divide this quantity, 7 raised to 2016 plus 9 raised to 2016 by 64. If we divided by 64, the remainder will be 2. So another thing to note here is that sometimes one may be tempted to use a calculator in this, but the calculator will not be very useful. So in such cases, the students have to sit down and do some analysis of the problem and figure out a way that how they can reason out the answer, because the calculator will not be useful at all in computing this. Okay, so we'll move to the third question. So this question asks, given that square root of 2x plus y plus the square root of x squared minus 9 is equal to 0, find the values of y minus x. So that is, if there are more than one possible case, then we'll have to find the values. Otherwise, there may be just one. So we use the following assumption. When we have this square root sign, so usually it means the principal square root. That's a positive square root. So here we have two positive numbers, and we are adding them to get 0. So I think what the square root can also be 0. It doesn't have to be just positive. So 0 is a possibility. So they are not just the positive square roots, 0 is included as well. But the only possibility you can have here is that both of them must be 0, because if you're adding any two numbers and they are not negative numbers and you get 0, then the only option is that both of them must be equal to 0. So we use that in the next step. We have 2x plus y must be equal to 0, and x squared minus 9 is also forced to be equal to 0. So we can find the value of x here by solving this second equation, and that will give us x is equal to plus or minus 3. And we can find the corresponding values of x. When x is 3, we'll have 6 plus y will be equal to 0. That gives us y will be minus 6. And the question asks us to find y minus x. So y minus 6 would be 6 minus negative 3, which gives us positive 9. So when x is negative 3, then we have minus 6 plus y is equal to 0, so that y will be equal to 6. Did I make a mistake? When x is negative 3, y is positive 6, right?
Yes.
Yes. Yeah, so 6 minus -3 will give us +9. But when x is 3, y, which one will give us? When x is 3, y is -6, so it's fine. So we'll have -6 minus 3 to give us -9. So I think that's correct now. We have the final answer. So the trick here was to realize that if you add any two non-negative numbers and you get 0, then both of them must be equal to 0. And after that, now that was a breakthrough. And then from that point onwards, everything flows. It's just a little manipulation of the equations and expressions, and you get your answer. So the values are 2, and they're both both are listed here, -9 and 9. So we'll be going to the last question. Question 4. So this question asks us to find the maximum value of this sum, the square root of x minus 144 plus the square root of 722 minus x. So the route we chose for this was to work with the AM-GM inequality. So what we do is first create something that we can use to simplify our work. I suspect there might be other ways to solve this. This is only one of the ways to solve this. And probably if you try to solve it on your own, you may have come up with a different, more direct technique. But this one is just to show that sometimes you have to come up with a setup which makes it easier for you to solve. Go to a more general setting so that you can now apply the general setting or the general results that you obtain to this as a special case. So the AM-GM inequality for the simplest case where we have only two positive numbers, A and B are positive numbers, and then their average will be greater than the square root of their product. We can rewrite this and switch sides so that the square root of AB will be less than or equal to A plus B over 2. Can go further and multiply so that we have 2 root AB will be less than or equal to A plus B. So if we add A plus B to both sides, on one side we have only 2 root AB. So if you add A plus B, this is what we get. On the other side, we have A plus B. So if you add another A plus B, we get 2 of them. And that's how we end up with this second inequality. And you can observe that on the left-hand side of this inequality, the square root of A, it's actually equal to the square root of A plus the square root of B in brackets squared. So now this gives us that the square root of A plus the square root of B to bracket squared will be less than or equal to twice the sum of A and B. We take off the square root and we can now conclude that the square root of A plus the square root of B should be less than or equal to the square root of twice the sum of A plus B. So now this is in a form that appears here because we can take A to be X minus 144 and 720 and B to be 722 minus X. The question asks for the maximum value of X. So it's important that we know if this maximum can be attained. And yes, it can be attained if when A is equal to B, and that means when the square root of A is equal to b. So this will actually give us a maximum value that can be attained by our expression. So if we make the substitutions, a to be x minus 144 and b to be equal to 722 minus x, and the maximum value of x minus 144 plus the square root of 722 minus x will simply be equal to the square root of 2 multiplied by the difference of 722 and 144. And when you work this out, this should be the square root of 1,156, which is just 34. So this gives us the maximum value of the expression we have up here. That's all. That's all the questions that we had to cover today. You are free to ask anything related to this that may not have made sense, or any comment or suggestion is welcome now. Maybe I'll stop sharing. Is there any question on this? Or should we bring harder problems next time? These ones were a bit light.
Got a question on problem 3.
Problem 3.
Yeah,
of the second set?
The set you just shared.
Pardon?
The set you just shared.
Okay. Just hold on. Now, which one did I just share? Was it this one?
The first.
This one?
Yeah.
So,
case 2, when
are you using 2 gadgets? There's a bit of echo on your side. Hello?
yeah, the second case, when let's say if we had a and b, a plus b equals to 0, the case when a is negative b.
Now that is not possible because the square roots are taken to be non-negative, right? So none of these can be negative. Because the assumption here is when you take the square root, this radical sign normally means you pick the positive or 0 square root, the non-negative square root. That's usually the assumption. So that is where that's where our logic comes from. I don't know if you are convinced now. Tito, there's a bit of echo from your end. I don't know what is. Oh, where is the echo coming from? Are there any more questions or comments? Looks like there are no more. Now, I would like to mention the following also. We, since last year, we got a company to sponsor the KAPEK Kenya Mathematical Olympiad, and the representative is here. That is Beatrice Wagishu. So I would like to invite her to speak to us as well, because I think now they're also involved in a lot of communication. They are now part of the team running the competition. So maybe it's useful for everyone to also know our sponsors. So Beatrice, are you
James.
ready to talk?
Yes, I'm actually, I want to start my video, but for some reason, okay, there we go. Can everyone see me?
I can see you.
Okay, great. Thank you so much, James, for starting off with this teachers training. You can see we got a couple of teachers on. I'm sure in the next session we'll have even more. I just want to say a few words. Like last year when we started sponsoring the KKMO, James had a lot of ideas. Now he was talking about the teachers training, what to do in terms of communication so that we make sure that we reach as many schools as possible and more schools actually participate in comparison to the previous years. And I think he's done very well working with him, communicating and providing all the support he can to be able to reach those goals, to get out to many schools as possible, to know about the competition and actually get more schools to enroll. So that is still the target, that is still the goal. We were set back a little bit because of COVID, but that was the case with many companies, many institutions. So we'll just work with what has been given to us. Things are coming on well. I'd just like to mention a quick thank you for the work done with the second round. We've just closed down on that, and it was fantastic that all the schools participated in it. So right now, the marking is ongoing. So the next bit for now is to give more schools a chance to participate. And between now and when the 2021 round will start, we have ample time to make sure that the schools that have never heard about this before actually participate. So we would like for those who've been participating in this competition, give the word out to more schools, anyone who's never heard about the competition, anything we can do to make sure that every single school knows about this competition. We would like to have them on board. So the next 2021 round starts in June 10th, but between now and May the 31st is when the registration is ongoing. So please participate in this teachers training, get yourselves ready to ready your students as well, and ensure that more schools join, ensure that more students join. We shall be, I know I have spoken to some of the teachers, actually most of the teachers who participated, about the KAPEK giveaway for the students who participated. So even if the students participated and they didn't qualify for the second round, we were supposed to give a KAPEK calculator set to each and every one of them. And I do take this opportunity to apologize that was not possible to happen in January as had earlier been communicated, but we're still on course to go ahead and continue with that, continue with the giveaway in April. And I'm sure everyone received that email. In case anyone did not, please shoot me a quick email or a text me in the group to make sure that the communication reaches you. Otherwise, apart from that, thank you so much for your participation, for your comments. Even as we start this teachers training, as James comes up with content to prepare the students and to prepare the teachers, please let us know your feedback on what is going well, what is not, what you feel could be an improvement on the competition, because we want this to grow much, much bigger, and we want our math geniuses to be recognized on an international level. So I thank you so much for coming on board. I think this was put out on Thursday within such a short notice. Thank you so much for participating. We'll make sure that this is very, very regular, and James and his team are working hard on that. So kudos to them. And I look forward to working with you more. Yeah, so that's all for me. Thank you so much for joining.
Okay, thank you very much, Beatrice. So we are very grateful for the support we get from KAPEK, KAPEK Mathematical Instruments.
Oh, we're happy to be working
Yes.
with KMO. Yeah.
So a good way to make this work, the training, is to have clubs, the mathematics clubs. I think I can see Mr. Ondunga is here from Alliance Girls High School, and he has set up a maths club which works very well. I don't know what the numbers have reached now. I would like to invite him to say something about how this has worked for him and the club, maths club in his school.
So good evening, colleagues. I'm very excited to be part of those who are learning this. We discovered early that the only way to have this working is to have a maths club that really works. Also because in some of our schools, the support from the admin is usually limited. So we were also using the clubs in terms of registration and subscription to be able to facilitate some of the activities. Like initially would be able to get somebody to come and train the students and we pay them. Of course, this is COVID season, so that is not possible for now. But it's still a good idea of helping support. Like when we say that we have round one in June and students will be paying some limited amount. If the club has funds, then it is able to pay for some of the students who are very gifted in maths, but are not gifted financially. So really maths should be at the center of our hearts in terms of facilitating and helping all those students who are gifted to be able to participate. But I also want to urge my colleagues, because over the years I've realized that somebody may be a very good maths teacher, but has absolutely no interest in this kind of stuff, just because it is very demanding. So I would urge all of us who are in schools to encourage our teachers to get involved. Some have more time on their hands than others. So let's encourage them to get involved. If you're very smart in maths, then it's supposed to help you do a lot of things in life. So some of our students, the only way we help them is to engage them and to register them in an event like the Maths Olympiad, so that way they'll be able to get more help more easily. And that's why the teachers are very central to making sure that this works. I'm very excited when I see my colleague teachers from all over the place hooking into this program. And I believe that in the next program like this, which I think is on the 8th of March, then we should be able to have more people participating so that we are able to really rope in all our students to be in this program. Otherwise, thank you, and a big thank you to Dr. Katende, who keeps on working at this over the years, and we believe that it shall be well. Thank you.
Okay, thank you very much, Charles. Charles has been very supportive, and Alliance Girls High School, whenever we've had to train the students for the International Math Olympiad and the Pan-African Math Olympiad, they have been hosts for the team before. It's just that now we have COVID, so it may not be possible to host any team in the schools. But they've always been supportive in terms of hosting the training for the team that goes to the International Math Olympiad. So if there are no more questions, I think we have come to the end. Maybe what we can do is, can we get some comments on how the second round was? Anybody? What were the comments from the students about the second round? Did they find it accessible, or was it
yes.
too much?
Hello.
Hello.
My name is Zadok from Garissa.
Karibu Zadok.
Asante sana. For me, I had an issue. The communication didn't reach me in time, but I thank you very much for sorting me out. Although I understand the issue was with my WhatsApp. Up to now, I'm not yet in that group. I was there once, sometimes back, and then after I had an issue with the WhatsApp, I lost the group. Then coming back, I didn't inform you so that you add me to the group. So I believe that is the reason as to why I got the communication a little bit late. So my students were not very well prepared, but I believe things are okay. And sometimes when you are communicating through the other group, my WhatsApp group, the math teachers, you can also just communicate there in advance so that those who are not on this side can also can also know what's going on. And some others who do not know what is going on can also join us from that side. Hello?
Hello. Yes, thank you very much, Zadok. We will try to make the communication a little more smooth. What we can also encourage people to do is to, I'll just put the website in the chat. Our website is KKMO official.com. I've put it in the chat. So this would be a good place to check for any new activity and any announcements that will be available. Then you can also look for, on Facebook, you can look for KAPEK Kenyan Mathematical Olympiad. If you look for that on Facebook, yeah, so usually there are some updates that go there. So in case you would like to get updated in, if you haven't seen anything in the WhatsApp group, you can also reach me directly, or you can check on any of these platforms. Okay.
Okay, thank you.
So thank you very much. I think we are, maybe it's good to say that eventually we shall set up some trainings where we cover particular topics. And like I said, we may also be partnering with Andreas Holmstrom from Sweden. And now he's in Norway, though. He's also in the meeting. He spoke a little earlier. They are setting up some training program for Norwegian students, and if it works out well, we can partner with them also in the same program for Kenyan students. So with that, I think I'd like to say it brings us to the end of the meeting, and we look forward to your attendance in the next meeting. And please, you can tell us in the group if there's a better time to set up the meeting so that we have more attendance. So with that, I'd like to wish you a good night. See you again in 2 weeks.
Okay. Thank you so much, James, for conducting this. Have a good night. Good night, everyone.
Okay, thank you.
Good night.
Thank you.
Thank you.
Okay, good night too.